Hayley, Boles, thanks so much for meeting with us this morning. Please start off by telling our listeners a little bit about yourself and how you got involved in space.
Sure. I was born and raised in Gainesville, Florida, which is home to the University of Florida. And I essentially in high school wanted to make sure that when I went into college, I was going into a field that I could just be helpful at. I didn't really have a desire to be the best. I didn't want to turn a hobby into a type of job. I just wanted to be helpful. And so I basically looked at all of the classes I had been doing and noticed that I was particularly good at math and science. And so I kind of looked at the fields and went, okay, well, I'm pretty good at biology. And I didn't have the financial means to go to a four-year university right when I got out of high school. Okay. So I decided to enroll in my local community college. While I was there, I took an astronomy course. And this astronomy course, at the very end, they had a whole presentation on a field called astrobiology. And I was like, whoa, this is really cool. And the beauty of community colleges is the campuses are really small and it's a lot easier to connect with professors and faculty. So after class, I just walked up to the professor and was like, this is really cool. I'd love to learn more. Is there any opportunities for me to get involved? Being like a community college student at a university or college that didn't have any dedicated space research. And so we started hunting around online and found NCAS, or the National Community College Aerospace Scholars Program. So I applied to that, I got in, and it was a really awesome program that taught me all about NASA's history. And I kind of fell in love with their culture and how they approach problems and their ideas of how important diversity and inclusion is. And so that's what kind of started my interest into space research, is simply because a presentation by my community college astronomy professor introduced me to it.
That's really exciting because, I think as we were talking about earlier, as we were logging in, oftentimes students today think that there's one path to something, when in reality, a lot of times you think you're on one path and you hear something from someone, in this case, a professor that you had, and it kind of sparked an interest as you're going. So you don't have to necessarily know 100% your path when you're first entering, community college or college, because you might find something even more stimulating along the way.
Well, and I was always told that, like, going to college, most students change their major 8 times. And so I immediately went into college with the mindset of like, I don't know what I want to do. So I was undeclared and always looking in different classes that I was in for different topics that interest me, to see if that was a way that I could, move forward with my life, my education.
Now, you said it was an astronomy professor, but it was an astrobiology
lecture.
Yes. So how long before you heard that lecture until you said, this is the field that I would like to be
in? Probably after I finished NCAS. So the lecture I was in fall, and I did NCAS in the winter section. So NCAS finished around March of the following year. So probably 6 months, somewhere around there, is just because I wanted to finish out that program and see, like, majority of the astrobiology research seems to be supported by NASA. And so if I want to get in this field, I have to really enjoy NASA and how that organization functions. And if I don't care for how that organization functions, then this probably isn't a field I want to be in.
So you mentioned NCAS a couple of times, and I want to make sure I'm getting that right. And actually, I want to make sure I write it correctly because I want to maybe link it in the notes. So can you tell me what that is again? And then also, you said that you found that because the professor started to help you search for possible programs. So is it a separate program from your school, or did you get credit for it?
Yeah, so you don't get credit for it. What it is it's essentially an external program. And it's NCAS, or National Community College Aerospace Scholars Program. It's something that you would do in your own time. And it's a really awesome program because essentially it starts with if I remember correctly, like a 10-week online program that's basically your own time to go through the online modules, similar to like an online course. And then there are little quizzes at the end. And so long as you score well on the quizzes, they'll move you on to the next part, which is actually where you write your own research paper. So you're supposed to partner with a faculty member at your community college and come up with a mission design. And it doesn't have to be crazy in depth. The paper was only like 5 pages, 5 sections. And you actually submit that paper to the NCAS committee, and they send it to professors at different colleges to grade it. And so long as you do better than like a 70, so you put some effort into it, they will invite you for the on-site experience. So they bring you to a NASA center. They pay for your flight, your food, your housing. It's totally no cost to you. And so I ended up at the Stennis Sea Space Center, which is where they test the engines for the Space Launch System as well as the other rockets. But other members of my NCAS cohort went to the Kennedy Space Center. Some of them went to JPL, some of them went to Marshall. They try to make sure that you aren't going to the center that's closest to you, because they want you to experience more of the NASA network. So of course, the center closest to me being in Florida would have been Kennedy. But they said, okay, well, let's not send her to Kennedy. She's probably been there a couple times. Let's send her somewhere else. So they sent me to Stennis. And so during the on-site experience, they have a little challenge where you essentially get a little rover, and they have a Mars yard, and you have different goals set every day, and you work with a team, and everyone gets assigned roles like safety officer, computer science, the software engineer, the mechanical engineer, electrical engineer. And you work with a whole bunch of students from all across the country building your rover. And my team came in second, which was a bummer because we were winning every day. And then the very last day, the other team came in and they won the like high ranking prize.
Oh, always, so right? It's always like you've got the record, and then on the last day, it's one contest. That doesn't make sense. That's not right.
Yes, exactly. So that is NCAS in a nutshell. They run it 4 sessions every year: spring, summer, fall, and winter. And I highly recommend it. It's awesome. It gives you such an amazing connection for people that you wouldn't necessarily interact with. Like I met the engineer who designed the cupola on the ISS.
Wow.
And he's a fascinating individual because he is a Black male from the rural parts of Louisiana who went to community college and then went to Louisiana State, if I remember, LSU, and then just found himself interested in space in the same way that I did.
That's fantastic.
Great story.
What do you think, how likely was it that this experience set you up to get your first internship at NASA? Very
likely. When you apply for NASA internships, they ask you if you've done any other NASA programs, and one of the first ones on that list is NCAS. NCAS is also amazing because once you finish the program, for summer internships, they will actually put up funding for you, which gets you much more likely to get a NASA internship, because if you come with your own funding,
yes,
and you apply, you're free to them. So they're much more likely to accept you.
That's great because you're not pulling out of their budgets. Yes,
right.
Exactly.
How long was your experience in Mississippi at Stennis?
It was only 3 days.
Oh wow! So it's really compact and probably.
Yeah, but I mean, they filled every minute. They filled
long days.
Minute. Yeah.
That's great. So you finish your NCAS experience. Are you still? Have you graduated community college yet? Have you been accepted to UF? How did that sequence of events line up?
Yeah, so I graduated community college, if I remember correctly, in 2017. And then I transitioned over to UF the following semester. So I was at UF fall 2017. And I decided to pursue a Bachelor's of Science in Microbiology and Cell Science. I had been looking at a lot of research, and it was recommended by the astronomy professor I had been speaking to at my community college, who, was looking at all of these posters at conferences and talks, and he's hearing a lot about microbiology, bacteria, fungi, things like that. And his piece of advice was, it sounds like biology is your field, and it looks like microbiology is the main focus within astrobiology. So it looks like if this is what you want to do, microbiology is the field to go into. So I transferred to UF for a bachelor's in microbiology.
Was your community college in was it is TCC the one that's in Gainesville? Or were you elsewhere and then you were able to transfer into UF because of your experiences?
No, I was in Gainesville, so our community college is called Santa Fe College.
That's it, Santa Fe.
Yes,
TCC is,
yes.
yeah, that's right, Santa Fe. I lived in Newberry of all places, so like, so I know, I was like, I know there's something there. Okay, so you were there, and that was, the natural next step would have been UF. So I'm sure that all of your experiences with that NCAS also helped.
What was the first day of going to class at UF like? How was that maybe contrasted to your experiences at your previous school?
Well, I'm a bit biased because I was born and raised in Gainesville. So I've been on UF campus pretty much
Oh,
since I was born. So for me, it's not too much of a transition, but I can say that it is definitely a difference in culture when it comes to how you approach classes, how you interact with other students, how you navigate the campus. Because coming from a community college where the whole campus is very easily walkable, to a university where my microbiome building to get to the main lunch hall is a 30-minute walk one direction, is quite a different experience. So as far as my first day went, I made sure that I went ahead and found all of my classes beforehand because campus is open.
right.
Just to make sure that I wasn't going to get confused. I figured out the bus routes beforehand because I couldn't walk everywhere I wanted to go. And then I basically just did my best to talk to people because with community college classes, it's very much an experience of, just doing well in your classes, and it's not so much understanding how the exams work versus if you're at university, you can know all the material you want. But if you're not communicating with others and figuring out like, oh no, like this is really just the material you need to know. Like this is how this professor tests. This is generally what's important in this class. And that's stuff that you won't find out unless you speak to others who have already taken the course or are also currently taking the course. Does
Right.
that make sense?
No, absolutely. Even 30 plus years ago, in the chemistry department, you would pay $1 or something and get old copies of tests to see the kind of test, the kind of questions that were asked. And then you would hang out in these common areas where the grad students or upperclassmen were tutors, right? It was like free tutoring, and you wanted to pick their brains and learn everything you could. You wanted to game the system, right? You wanted to understand the rules. So I totally get that. And did you have, did you still have it at your, in this era that you're going to school, did they do the fill in the bubble test on the high, sort of like the early classes where they're, I had 700 kids in one of my chemistry classes one year, and we only took tests by OpScan, the fill in the bubbles, and there were 20 questions and you missed 2, you were about to be, you couldn't miss more than 2 and you didn't have an A. So it was, I don't want to say it was high stakes. It was tough because there was no such thing as partial credit. Did you have those kinds of experiences early on, or did you not see that at UF?
I just graduated in May 2022, like last month, and some of my final classes we were using Scantrons.
Okay.
They still use
technology.
Scantrons, and getting an A is still definitely a challenge, especially at UF because UF does not do the solid grade system like A, B, C. No, it's an A, A minus, B plus, B, B minus, C plus, C. And so they basically do everything they can to form a gradient of the students and their performance. So getting an A, it is a challenge.
Oh my goodness. The toughest class I ever had, one was biochem, and the professor said, I don't know how many were in the room. He said, only 3 of you are A students. The rest of you will fall on the bell curve, and I look around and I go, I'm not the smart guy. So what was your...
I've had classes where the grading system, they have a policy where only the top 5% get an A. It doesn't matter what the score is for,
right.
Like, it's not, you need 270 out of 300 points. No. It's just the top 5% get an A.
Wow.
And the next 15% get an A minus, and it just goes down. Yeah,
That's
there is,
interesting.
you just basically have to outcompete your classmates.
I hope
That's
some
all
of
it
our
is.
parents are hearing that. We have
Yes.
parents sometimes who are like, what do you mean
Well,
not an A?
Well,
Like
we
they
s-
need to know the
we
reality.
suffer a lot from gradeflation, right?
Yes.
In the younger grades,
Oh.
like your A is meaningless because 90% of the class supposedly
Got an
had an
A. Right.
But one of my proudest moments was I think I made a 37 on a test in biochem, and I was about fourth in the class, and I was like, yes, 37% was like a B.
Yeah, that's another learning curve, is once you hit university, you realize like getting a 50 is great.
Yeah.
Like, you've done great.
Yeah. Or
Versus-
my mathematical answer is within a magnitude of 10. I'm on there, right? So
yeah.
So let's talk a little bit about your internships, your work experience, and where you want to go in your life. So let's talk a little bit about conferences that you really enjoyed and the subject matter that you either presented at or were most interested in at those conferences.
Okay, so we'll start with conferences. So I've been to quite a few conferences. I've been to GSA, which is the Geological Society of America. I've been to ASGSR, which is the American Society of Gravitational and Space Research. And then I've been to AbSciCon, which is the Astrobiology Science Conference. So GSA, I actually didn't present anything, but GSA is a massive conference, easily 15,000 attendees, and it covers pretty much everything to do with the field of geology, which includes astrobiology because of the preservation of biosignatures within the rock record and things like that. So that conference was fascinating because you learn about an entire field rather than just, your small field of interest of astrobiology. Another conference of interest is ASGSR. Love that conference. That conference is amazing because it really is specifically for people interested in space biology or astrobiology. So you will see booths there from different contractors trying to help people build their hardware for their experiments. And then every presentation you're seeing is directly about the progression of space biology and astrobiology. Then there's AbSciCon, and that field is fairly broad. And so you will get everything from preservation of biosignatures to a bit of space biology to a lot about the Curiosity and Perseverance rover data updates. It's truly just about the field of astrobiology, while ASGSR is more space biology focused. And so I've presented at both ASGSR and AbSciCon. AbSciCon, I did an e-lightning talk, which is just a 3-minute talk in front of an interactive poster. And then ASGSR, I did a poster on my research from my second internship with NASA, and I won the CASIS award. So that was very exciting.
Wow. Center for the Advancement of Science and Space. Now I believe they've been folded into or absorbed by the entity, the ISS National Labs. Yes. Does the ASGS, the gravitational biologies, that conference, is it always in Washington, D.C., or does it move to different cities every year?
It rotates. So last year it was in Baltimore. This upcoming year it's in Houston, Texas.
Got it. All right. So now you're a recent grad. Congratulations. Tell us about if you're able, what's your next steps, and what is the area that you either are going to work in, or the area that you most likely that you would most like to work in down the road.
Sure. So, I mean, my dream job would be working as a space microbiologist at NASA. But of course, that role is a bit specialized. So my current plan after graduating is I'm actually going to go work for a year or two, because I have a dream of going to graduate school, but I'd like to go for a master's. It's difficult to find a funded master's. Most funded graduate school work is for a PhD. And so some people do choose to take a PhD and then basically master out of the program. But in case that's not something that I want to do, I'm basically going to go work for the next 1 to 2 years, build up my savings, and then go apply for grad school so that I'm financially stable when I'm
Yeah,
in grad
right.
school for my
that makes
master's.
sense.
Yeah.
Is there a program in Florida that interests you as far as a master's?
It's there's not one program in particular. When it comes to approaching science, you don't necessarily look for a program, you look for a professor. So what you do is say, I'm interested in biofilm research. I actually go on Google Scholar and I start reading papers. And I think to myself, okay, you know, what about biofilms interests me? Maybe it's their dispersal, maybe it's their formation. Maybe I want to engineer surfaces that can prevent biofilms from adhering. And I'll go find researchers at universities who are actively working on that. And then I reach out to them and say, hi, I'm really interested in this topic. Do you have any space in your lab to take on a master's student? And that's more
Okay.
how it works in
Wow.
science.
That's an interesting
Right.
approach,
The
actually.
reason I ask is that Dr. Mukherjee at the Florida Space Grant Consortium, they offer a scholarship every year for a master's student. And I was just wanted to know if you were aware of that.
I am, because I work in a lab at UF with Dr. Amy Williams, and she's gotten funding from them 3 separate times for
Oh,
her
good,
students.
good.
Okay.
Yeah, he's a great guy. He's been pretty helpful, and even funding some of the things that we're doing with younger kids. For our listeners, I know you've told us a little bit about what astrobiology is and some of your interests, but like, I'm not sure that our listeners might understand completely what that realm of study would be. So if you were to give us a little nutshell example of what an astrobiologist does, what is that?
Sure. So an astrobiologist is essentially someone who's looking at the detection of life elsewhere in the universe. So an example I can give you is the project that I work on at the University of Florida for my astrobiology project with Dr. Williams. So I essentially look at the preservation and detection of organic biosignatures in ancient cratonic rocks, ranging from 1.1 to 3.2 billion years old. I know it's a mouthful, but really all it means is that there were microbes living on these rocks a long time ago. They died, and they left organic molecules in these rocks. And so we want to know what organic molecules they left behind, so that if we see those organic molecules on Mars, we can go, oh, we know what that's from. And then we backtrack. So that's more the astrobiology world, if that helps. And then space biology is more about understanding how living things on Earth respond to the spaceflight environment. So that's taking plants and putting them up on the ISS and saying, how are they responding to the radiation, the microgravity, the high CO2 levels on the ISS, all of these different factors. And so that's kind of the difference in the fields.
Right. So it sounds like life in space versus human life in space. So like
Right.
how you're determining the first one, you might see similar occurrences from different locations in space, different planets, different things where there are similarities in the life forms that may have been there that are evidence versus how what we're used to here on Earth would adapt to those forms in space. Yes?
Exactly. Yeah. And space biology is also, there's a lot of research going on for benefits back on Earth as well.
Right.
Right.
So,
Yes. How do we optimize what happens up there for us? How do we take life here up there and make it work? I think growing food is a really big thrust area. I had read once that there are no telling how many millions of species we'll never know about on Earth because they arose and they became extinct, but such a low percentage of specimens get fossilized that we find. Can you shed any insight into maybe how much diversity of life we may have actually had on Earth in the past, but we haven't found or can't find any record of it?
well, that's more a question for a paleontologist. And I know one I can put you in contact with if you'd like to learn more. But yeah, you are correct. Quite a few organisms live and die and never get fossilized. And so it is quite a challenge to figure out, what was the diversity that we had
Right.
during one time period in the geologic time scale versus another.
And if you're looking at really small things or aqueous, things that were mostly water, they don't leave a lot of remnants, do they? And can you give us just a little insight into your world with respect
It
to that?
is very difficult for soft-bodied organisms to preserve. I do know that. So it is very rare to see a jellyfish fossil or a sea cucumber fossil, just because they were soft-bodied versus something that had bones. Bones are a lot easier to fossilize. As far as the preservation of microbes, the big one is stromatolites. So if you've ever seen pictures of those or anything like that, essentially microbes will take in calcium and then basically produce, like, it almost looks like layers of sandstone. It looks like you're looking at a croissant made of rock. It really does. And so there's just layers and layers and layers, and we know that they were created by microbes. And so depending on the deposits within these stromatolitic layers, you can learn a lot about the climate at that time, the health of the microbes at that time, the water temperatures, different concentrations of ions in the water at that time. So that's the most obvious example I can give you as far as like preservation of microbes over time.
Yeah, I apologize for pressing you. How do you know a stromatolite secreted a film? How do you, can you just in the simplest way for our audience, how do you know that was of bacterial origin in the fossilized record?
I mean, I'll be honest and say it's not my specialty. So I do know a few
She's
people.
saying that was
But you know more
paleontology.
than we do. You know more than we do. So
I really couldn't say. I mean, again, you would just have to look at the features of the rock and also the location.
okay.
Well, my last question will be very easy, and just for the sake of time, we kind of are at the end of this interview. But kids listening, some advice that you have for people who might be interested in this field and are just kind of getting started, either they're in high school or they're about to graduate.
Yeah, so if you're interested in astrobiology or space biology, I recommend that wherever you end up going to school, whether it's a research institution or not, read about it. It sounds very simple, but the more you read about the field, the more you learn about it, the more likely you are to learn about opportunities within the field if you wish to pursue it. Um, when I was at my home university, I was reading about this new professor who just moved to UF and was looking for, research associates to help them out and volunteers. And so that's how I got in touch with Dr. Williams, working on preservation of biosignatures. Reading about, microbes being put on the outside of the ISS or tardigrades making it to the moon, all of this stuff, it captures your curiosity, it keeps you connected to the field, and eventually it will get to a point where you see something that you can add to, and that's when you reach out and say, hey, I think this is an amazing project, I'd like to get involved, here's my background, let's do it.
So reach out, like I get it. That's a lot of times kids are just afraid, just to even send an email, but obviously you have to be proactive and advocate, because if you're not, everybody else is. So just
yeah. And the other thing too that I love to tell people is, like, scientists love to talk about their science. Like, who wouldn't love someone coming up to you and saying, what you're doing is super cool, can you tell me more about it? Like, who would ever be offended by that?
Right, you're right, absolutely right.
Right.
Well, thank you so much for spending some time with us this morning. We really appreciate it, and I know that we've got a lot to look into with regards to NCAS and stromatolites, or did I say that right? Stromatolites, all kinds of fun stuff. Thank you again so much.
Of course. Thank you for having me.
You're very welcome. Thank you.